And now the interesting thing is that we can reuse our template, or in other words our type parameters. As you can see in the example, we can reuse our type parameters for non-type parameters. In this case we have a pointer to a type of t1. We can also use them to specify default type arguments for other type parameters. In this example we provide a default type argument for type parameter t2 by reusing the type parameter t1. In this example I have struct entity again. This is a template. We have type parameter t, and then we basically have a non-type parameter pt, which is a pointer to that type t. Then I have some global variable x, which I initialize to 55, and then in main I construct entity, and that is going to be of this type, so entity. Between angle brackets again you have the argument list, so I pass an integer for the type parameter, and I do the address of x for the non-type parameter. We are simply reusing the type parameter t to basically accept a non-type parameter, which is going to be a pointer to that type parameter t. In struct entity I have this t get value function that is going to return this right here, so I dereference that pointer. Okay, and back in main I have this statement cout entity.getVal, so it's going to dereference x right here, and it's going to print out 55. If I build a run, that is what we get, 55. Now of course this can also be a reference, and then I don't have to dereference anymore, and it's also no longer a pointer. So maybe I change the parameter name to RT, that is for reference to type t, and right here I'd simply return that, and I can just pass in x, build a run. That works fine, it prints out 55, and I'll change x to a float, and then I'll change the type argument to a float as well, build a run, and that will work fine. And the same thing if we do it with a pointer. So as you can see, it works with the pointer or with the reference right here. In a previous video I demonstrated non-type parameters, so these references or pointers to maybe a user-defined type such as an entity. In this case we are using x. It doesn't really matter, I'm just using x for simplicity here. But again, this is global or static, so this can be static as well. Build and run and that will work fine. Now if I try and build this here, you will get an error. So what we have to do is, we can make this non-type parameter constant right here. This is now pointed to that t-type constant. Build and run. Now it will work fine. If we put that in main, try and build that, you will get an error because it has non-static storage duration. Okay, because it is not global and because it is not static. Now of course you can make it static and build and run, and that should work fine now. Yeah, that works fine. Again, I'm just showing you this stuff because you can run into problems with it, and then you know how to solve those issues. You can sort of pass by value as well, so if I decide I want to pass by value, now again we'll have the problem of floating point template parameter is non-standard, so if you try and build that you'll get an error. Change that back to an integer and now we'll get a different type of error. So build that. Expected a compile time constant expression. And that red squiggly will now go away. If we build now, we'll get a different type of error and we get illegal indirection, and that's because we are trying to dereference that right here. So remove that, try once more, and that will work fine. Okay, I've reverted to the previous example and I've added a few more things now. In the entity struct template, we have t1 for the type parameter. Then right here we basically have a non-type parameter. Okay, so this is similar to what we've done in the previous example, but now we have another type parameter t2, but we can set that to be the same type as type 1. And I've made a simple change to the getVal function. It's going to return t2 now, which is fine because t2 is going to be the same as t1. So if you provide a type argument of int, then the type parameter t1 and t2 will both be int. That is why it is fine for us to return this right here. I'm going to dereference pt. Remember, pt is going to be a pointer to type of t1. We have this global variable x, which I set to 55. I construct the entity, which is going to be again of this type. I pass an integer, I get the address of x, and I do shout entity.getVal. I build a run and that prints out 55, so that works fine. Okay, so with these examples, I just wanted to show you that you can reuse your type parameters. You can use them as types for non-type parameters, and you can also set new type parameters to existing ones to make sure that they are of the same type. Now I have to say that this is a default argument, a default type argument. So T2 has a default type argument of T1. So if T1 is int, then T2 has a default type argument of int. And that is why here I do not have 3 arguments between those angle brackets, because if I do Ctrl-Shift spacebar, we can see that T2 has a default argument of T1. Now of course I can change that. I can explicitly specify that to be int, or maybe I can change that to a short or a char. Ctrl F5 to build a run, and you can see that works fine. As we've seen in previous lectures, we get all these types of problems when we work with non-type parameters. But as I've also demonstrated, there are some benefits when you use references or pointers, and when you reuse type parameters for your non-type parameters, because then you can have pointers and references to floats. So it is a bit of a hassle to use, but there are some benefits to it.